Okay, we're going to look at simultaneous equations with three unknowns. So for example, here's a set of three simultaneous equations with three unknowns, x, y, or z. So this could be A1, could be A2, could be A3, etc. If you're more comfortable with x, y, and z, you can of course change to x, y, and z if you're presented with different symbols here. So how do we solve this set of three simultaneous equations? The first step is to use substitution. And what we do here is we try to represent one of the unknowns in terms of the other two unknowns. So looking at x in this example, because x is probably the most easiest to deal with, take an equation 1 and we transpose for x. So x equals 9 minus y minus z. So x equals 9 minus y minus z. And the next step here is to substitute this into equation 2 and 3. So we transpose any one of our three equations for one of the unknowns, then we substitute that into the other two equations. So here we've replaced x and x with 9 minus y minus z. So in terms of solving this, what has changed? Well, what we've done is we've moved from a three unknown situation to a two variables are unknown. And we know that we can solve for two unknowns. So we've just got y and z this time, no x. But first of all, let's simplify. So the 9 would come across on both sides, both equations. And we'll also simplify the y and z. So minus y plus 2y equals y, minus y plus 5y equals 4y, minus z plus 3z equals 2z, and minus z minus 3z is minus 4z. So we've simplified that down to y plus 2z equals 14, and 4y minus 4z equals minus 16. And this is the same type of problem that we've dealt with before now, where we can use either elimination or substitution to solve for the two unknowns. The easiest way probably is often elimination. And to do that, we look at our unknowns, we look at y, and we look at z. And we ask ourselves, is there anything we can do here to eliminate either y or z? And remember, we can multiply one or both equations, or we can divide one or both equations to allow an unknown to be eliminated. Here we see that we have a 2z and a 4z. So if we multiplied this top equation by 2, we would have 4z and minus 4z, and we could use addition to eliminate. So we do that, we eliminate z, and then we add the other unknowns. So 2y plus 4y equals 6y, 14 times 2 is 28, 28 plus minus 16 equals 12, 6y equals 12, so y equals 2. The next step is just as before. Once we get one of our unknowns, we substitute it into one of these equations. So it looks like we went for this equation here, y plus 2z equals 14. So we put y equals 2 in there and we solve for z. So 2 comes across and we end up with 2z equals 14, so z equals 6. Now here's the key step, or one of the key steps in solving simultaneous equation with three unknowns, and this involves taking our two known values now for y and z and substituting them into one of our three original equations. You can use either of those three, but it makes sense to use equation 1 because there's no coefficients. So it's much simpler than substituting into the other two equations. So x plus y plus z equals 9. Substitute y equals 2 and z equals 6. And we can then transpose and solve for x equals 1. So there's our solution. X equals 1, y equals 2, and z equals 6. A good thing to do now is to check in the other equations that this is correct. So 1 plus 2 times 2 is 5, plus 3 times 6, 18. 5 plus 18 equals 23. And you can check in the other equations as well.